Hello students, so welcome to this new video on radiation heat transfer. Now in this video we'll try to understand two important concepts, that is, one is solid angle and intensity of radiation. So both are connected. First we shall understand what is actually the solid angle is all about. See, basically what actually solid angle is, before actually getting into the all the mathematical aspect of it, basically what is actually radiation heat transfer. Suppose say two bodies are there, okay, so two bodies are there like this. So this body, let us say it is body A and this is body B. Now this body is emitting radiation in all directions in a hemispherical manner. Also this body is emitting radiation in all directions in a hemispherical manner, correct? But this body which is emitting in all directions, if this body emitting radiations in all directions, how much of those radiation is incident on this body? Similarly, this body which is emitting radiation in all directions, how much part of this radiation is incident on this body? So that actually is what in some way defines the solid angle is all about. Understood? So we will get into the technical aspect, we'll get into the actual definition of solid angle. But basically in radiation heat transfer, if you want to calculate what radiation heat transfer exchange between body A and B, we need to find out this orientation first, how actually this body is seeing this body is seeing. So if you assume that you are sitting in A and seeing B, how much part of that B is you are able to see from A? That means if you try to see body B through A, how much part of body B you can see from A? Similarly from body B. So that orientation is somewhat actually given by solid angle definition. Are you able to understand? Now with this background we'll see. We'll first read out the sentence and I'll explain you in detail, okay? What is solid angle? It is defined as a portion of the space inside a sphere enclosed by a conical surface with the vertex of the cone at the center of the sphere. So how do we understand this? Is just a statement? No, it is not just a statement. There is a lot of meaning into it. It's not a two-dimensional angle, it's a three-dimensional angle actually. You should try to understand. Say consider some body is there. So and some body is incident on that. That means here some radiation is falling on that. So there is one more body above that. So what is that you need to do is take the perimeter of that particular body, try to join with the perimeter of this particular body and to the center. So from the center of it, try to connect all the perimeter. So which is try to form like a cone. Yes or no? Now keeping this as the center, take a unit radius. Take a unit radius and draw a sphere. Are you able to understand? Take a unit radius and draw a sphere. Since this cone is not a two-dimensional cone, it's a three-dimensional cone. It's a three-dimensional cone. The cone will be something like this. I think you will be able to understand. This is a three-dimensional cone, and from this center take the unit radius and draw a sphere. So what is going to happen? This sphere, it forms like a three-dimensional region intersecting this cone, correct? This cone and this sphere forms kind of a region in that cone. Yes or no? So that region is what is called as solid angle. Are you able to understand? So this region is what is called as solid angle. I hope you have got the concept. Now again we will read it. See, it is defined as portion of the space. So portion of the space inside a sphere inside a sphere enclosed by a conical surface with the vertex of the cone at the center of the sphere. So you take any area for that matter. From that center of that area, join the periphery of the other body, which is incident, where the radiation is incident upon it, where you want to find out the solid angle. So if you want to find out the angle, you need some other body, na? So this is dA, this is one more body. So try to join this body, the perimeter of that body, with this. Now keeping this as the center, draw the unit radius of the sphere. Now this region, whatever that is enclosed between the cone and the sphere, is what is called as solid angle. I hope you got the concept of solid angle. Now this is the solid angle actually is a three-dimensional angle. So it is not a two-dimensional angle. So you should be able to understand what is this solid angle. Okay. So with the help of this solid angle definition, now we will be able to define what is intensity. Intensity of radiation. Intensity of radiation. So intensity of radiation, which is basically I, is defined as the rate of energy leaving a surface is defined as the rate of energy leaving the surface in a given direction per unit solid angle per unit area of the per unit area of the emitting surface normal to the mean direction in space. So this is what the definition for intensity of radiation is. Now that we have defined the solid angle, now we will just read one more time. The rate of energy leaving the surface in a given direction per unit solid angle per unit area of the emitting surface normal to the mean direction in space. Understood? In a given direction per unit solid angle. So this is what is actually now if you try to do some sort of simplification, actually you can end up with expression for intensity. For time being I can show you that since I don't have a time. You can derive an expression for the intensity. The derivation of that intensity, the expression for that intensity of radiation is I is equal to now I will try to give the relationship between later we will try to define the intensity of radiation. I will try to give the relationship between emissivity and intensity. So it is related as E is equal to pi times I. That means the emissive power from a body is equal to the total emissive power of a diffusive surface is equal to pi times the intensity of the radiation. So we will get into the solid angle when we talk about the heat transfer aspects and all. There I'll in a very detailed way I'm going to explain you all the concepts of intensity. How do we derive the expressions for solid angle and for the intensity? So for time being, you understand that E is equal to pi times I, where I is the intensity, pi E is the total emissive power of a diffusive surface. Okay, this is very, very important for a diffusive surface. Now there is one more law which is attached to this, is what is called as Lambert's cosine law. So basically what does this law talk about is very simple. So what is the emissive power in any direction? Suppose say I have the radiation which is emitting in this direction. So what is the say this is the normal to that. So this is some theta. So what is the emissivity of the radiation which is emitting in that some particular angle with respect to the normal? So what is that we need to find out is, first thing is we need to find out, so that is how this is related. So this is En, that is E normal. So E theta is equal to En cos theta. En cos theta. So your Lambert's cosine law is what is this? E theta is equal to En cos theta. So how do we find out En? So what is this law speaks about? This law states that the total emissive power E theta from a radiating plane surface in any direction is directly proportional to the cosine of the angle of emission. So it is the emissive power emitting at any angle theta is equal to cosine times cosine of the angle with respect to the normal times the emissive power of the radiation normal to that surface. Are you able to understand? So that is what is called as Lambert cosine law. So let me write it. This law states that the total emissive power emissive power E theta from a radiating plane surface in any direction is directly proportional to cosine of the angle of emission. Cosine of the angle of emission. So if you try to remove that proportionality constant, you can end up with this. So finally that is what E theta is. En cos theta is going to become. So how do we find out this En? Similarly, En is equal to pi I. That is what it is. Now you can find out with the help of that intensity of radiation. Are you able to understand? So this is all about Lambert's cosine law. So we will see in the next case one or two problems we'll try to solve with whatever that we have discussed. All the laws, all the basic concepts of radiation. I hope the basic concepts of radiation is over. Next we will see how the heat transfer between two bodies is concerned through radiation. If there is a heat transfer exchange is happening between the two bodies through radiation, how does the expression turns out to be, how to calculate the solid angle, etc., all those aspects. Okay, thank you.